Hello everyone and welcome to week 4 of the Programming Valiance topic. I'm Patricia Shaw and this week I'll be revisiting some of the text-based programming that we've covered so far during this topic before introducing the text-based version of mapping. So why do we need to revisit what we've learned so far? Well, we've been covering lots of useful tools in terms of text-based programming this term. And when we are writing our programs, we need to make use of all of those tools at the same time. So we're going to have a quick revisit over those and then have a look at how we can write some mapping and what that mapping actually is using text-based programming. So during the course of this term, we have transitioned from the block-based programming that we've been doing previously with the microbits and the Arduinos and learning how to write the same programs using text-based programming. But not only are we writing the same programs, text-based programming does give us a lot more flexibility and control over the programs that we're writing. The catch is, it is a bit more fussy about exactly making sure we write it correctly. So we need to make sure that the spelling is exactly the same each time. But we have been able to reproduce the programs and expand on what we were doing previously using the text-based programming in order to control a robot. And alongside the text-based program, we have had a look at how to add comments into our code. And these comments are things that the computer ignores when it's running our programs. And so they can be really useful for us to help us remember what the code is doing. But also, if there's some code that we don't want it to execute at the time, but do want to keep because we might want to use it later, then we can comment it out so that we can keep the code in our programs without actually deleting it, but the computer won't run it when we run our programs. So really useful, and there's two different ways of doing that. We have the double slash at the start of the line that will then tell it to ignore the rest of the line. So it could be a whole line that it's ignoring, or it could be partway along the line that will ignore everything after it. And we've got this slash star star slash notation, and anything between that slash star and star slash will be ignored, and that can actually span over multiple lines. So we can have a multiple line comment. If we want to comment out a whole chunk of code, then that's quite useful rather than having to add the double slash at the start of each line. So introduce text-based programming. And of course, as part of the text-based programming, we're using an Arduino. We're connecting our sensors. We have sensors connected to the Arduino. We have outputs connected to the Arduino. So we need to be able to read and write from those pins. Now, of course, we also need to tell it what mode those pins are in, whether they're in input or output mode. But then once we've set up the pins for either input or output, we can read from them if they're input, and that could be, mostly we've been using the analog read from a pin number. But we can also do a digital read, and we were using both of these from the block programming side, and they have equivalent commands in the text-based side. Similarly for output, we've predominantly been using digital write for whether it's controlling an LED or the motors that were introduced last week. And the digital write specifies a pin and either high or low for the digital value. But equally, we can use the analog write option, which we were using to perhaps change the brightness of the LED previously. So we've got a text-based version of that we can use, which is much the same. We specify the pin number that we want to control and what value. So this is the number that we want to have at. And for an LED, it would be a number between 0, where it'd be completely off, and 255, where it's on full brightness. And we could specify a number anywhere in between those two. We've introduced variables. So variables have been really useful for helping us to specify the pin numbers at the start of our programs that we can then easily reuse throughout the program. We've also been using variables for holding readings from sensors when we want to get a reading from our sensor. When we're using the text-based programming, we have to remember that these variables have a data type associated with them. And we've looked at various different data types. Predominantly, we've been using the int or integer data type. but also mentioned booleans, so true or false, high or low. Um, and we could have a look at some other data types further down the line. So each variable has a data type associated with it. And when we're using a variable, we talk about assigning or storing a value to that variable. And those values can come from a calculation that we've done or a call to a function. And that function, for example, could be something like reading from a sensor. That is actually calling a function called analog read. And as a parameter, it's passing the pin that we want to read, and that's A1. And the value we want to store is always on the right-hand side of the equals, and the variable that we want to store it in is always on the left-hand side of the equals. So we end up with a statement that we're defining the data type of the variable, and this could be predefined earlier. We don't necessarily, if we're reusing an existing variable, we don't include that data type. And then we have the single equals sign, where we're then getting a value from somewhere. Could be a calculation, as I say, could be a reading from a sensor, and we're assigning that through the equals to our variable. And of course, we finish off with semicolon. And of course, with those values, those variables that we're storing, we actually want to use those in our program to change the behavior of the program. And that's using the if statement. So this is a really powerful tool that we use so much in programming to be able to change the behavior of our program based on some input, based on some conditions, some decisions that we want to make inside the program. And so we had to look at how to define these if statements. And so we have the keyword if, and then in the round brackets, we have some kind of Boolean condition. Here we're using less than. We also looked at equal to, where we actually had that double equals symbol for absolutely equals to some value. So if we want to make sure that our input is exactly a particular number, we have to use that double equals. But if we're happy to just see if it's larger or smaller than a number, we can use the less than or greater than. And of course, we don't have to be limited to a single block. We can have multiple conditions as part of our if statements. And that would be using this else if keywords followed by another condition. So we could have a range of different values, and depending on what the value is from the input, we actually want to execute some different instructions inside our program. And of course, we can have the else statement at the end that is like the catch-all if none of the conditions above are relevant. And of course, whilst we were looking at the if statements, we also looked at how to try and keep our code a little bit neater and easier to read by adding this space at the start of the lines whenever we're opening a curly bracket, and removing that space when we're closing the curly bracket, this indentation. And we have that for the functions, void setup, void loop. We have it for our if statements. And so you can end up with quite a lot of space at the beginning of a line because of the opening curly brackets. But it does make it a lot easier to check that the curly brackets are paired up, because remember, we always have to have these curly brackets and these round brackets in pairs so that they're opening and closing one another. If we have a mismatched brackets, then that will cause our program problems. And we did look at some of the bugs that they can cause. And so having this indentation makes it really quick and easy to check if your brackets are lined up for those curly brackets. So functions, we have talked about functions quite a bit, and we've used functions quite a bit, and hopefully you're recognizing some of the functions that are provided by the Arduino language that we're programming with and how we're calling those. But we've also, of course, started to write our own functions. And these functions are chunks of code that make it much easier to reuse and repeat the same task whenever we want to, rather than having to rewrite that chunk of code each time we want to do the task. So it helps to keep our programs much tidier and much easier to reuse as we go along. And in week 3, we were looking at writing functions for controlling the motors. So we had things like void drive forward or void drive reverse. And we had some digital writes in there specifying which motors needed to be turning in which directions. And that makes it really easy to then, inside our void loop, when we want to use that function, we just specify the name of the function. So as long as that name matches up. And with functions, it's really important to remember the round brackets, even if we don't have anything in between those round brackets. It's those round brackets that helps the computer to tell the difference between referring to a function and referring to a variable. So remember, with a variable, we can give it its own name, but there's no round brackets after that. Whereas with a function, we give it its own name and we can distinguish, we can tell that it's a function by adding these round brackets. If we don't add these round brackets, it'll think it's a variable and it will get very, very confused very quickly. So when we're using that function ourselves, we have to remember those round brackets. And of course, we follow it with the semicolon. As I say, we can use functions with values inside them. So this digital write is calling one of the Arduino functions. This delay is calling another Arduino function. And both of those are taking a different number of what we call parameters for executing that particular block of code. That means they can customize what it does each time you call it. So having recapped and revisited what we've done so far, I wanted to come back and have another look at mapping. Now, mapping is something that we have done before. We've done it with the microbits and we've done it with the Arduinos, but we've always done it in block-based programming. But I just thought it would be quickly useful to remind ourselves what this mapping is and why we need to do it. So let's take a range of different sensors that we've used. So we've got the LDR, we've got the potentiometer. Some of you might have also had a play around with the temperature sensor. And as an output, we also have the LED, one of the various different outputs. And each of these, if we're reading from the sensors, have different ranges of values that they return. So for example, the LDR will return a value between 6 and 679 when we use the analog read on the LDR. The potentiometer has got a different range of values, and the temperature sensor again has got a different range of values. And of course, if we want to use the LED, then as an analog output, we have a range between 0 and 255. So what this mapping does is it means that we're able to convert or map over one of these ranges into the equivalent value of another range. So if we had the midpoint of the potentiometer, for example, we could map that number, which would be around about 500, onto the mid-range of the LED, around about 125. Not exactly, but around about. Now in the maths, in the block-based programming, when we were using this, we only had 3 values that we could put into it. We had the input that we wanted to map, so this could be the sensor reading that we were taking and wanted to convert to a different range. And then we could specify the output range that we wanted to map it to, what the minimum value for that was and what the maximum value for that output range was. And this map block would sit inside another block because it's returning a value to us that we can then use in other places. Now, when we're using it in text-based programming, it actually gives us a bit more flexibility and control over the mapping that we're doing. So we've got our map, the name of the function that we're calling. It takes the input that we want to convert from one range to another. And we can tell it a little bit about the input range as well this time. So we can actually specify what the minimum value for the input is and what the maximum value for that input is. So if we want to convert it between the LDR, we'd have a minimum input value of 6 and a maximum input value of 679. We can then specify what the range of values is for the output. And if we're doing it for the LED, then that would be 0 to 255. So we can now take our input and tell it what range we want to start from and what range we want to end up in. And that will then return a number to us that we can then make use of in our programs. And we might want to store that number in a variable. We could use it directly somewhere, for example, in an if statement, but that's quite a long line to include in an if statement. So it might be easier to store it in a variable, making our program easier to read, and then we can just reuse this result variable that I've created here in order to be able to make use of that new value elsewhere. So let's have a look at how we actually find out these ranges. Well, if we're taking it from an input from a sensor, then the first thing we want to do is read from that sensor. So we could write a small program that would read from our sensor. So we're using the analog read from a particular pin. And then we want to be able to print that out on the serial monitor so we can actually show ourselves what that number is. Now do remember that if you are using this serial.println, print line, then we do need to make sure that's initialized in the setup function. So that would be the serial.begin, and then in the round brackets the magic number 9600, in order to make sure that this serial monitor is started up, ready for us to be able to print values to it. Once we've got that all set up, we can then run the simulation, show the serial monitor, and we can then actually see those values changing as we adjust the sensor in Tinkercad in the simulation. And so moving it from one extreme all the way up to the other, we can then find out what those minimum and maximum values are, and we can then update our program to make use of those. So what would that look like? Well, for the LDR, we've already said what the ranges are, but we could write it here. My input equals the analog read from my LDR pin, and I'm going to use a map to take that input. I've got the ranges for the LDR, and I'm going to map it onto the LED range, and I'm saving the output from the return value from that map into my variable. I'm storing that in my result. I can then use that as an analog write to the LED with using the result as the value there. And that would adjust the brightness of the LED based on the reading from the LDR. Interestingly, you could actually convert these to the other way around. So 6 is when it's really dark, 679 is when it's really bright. So would you want it to go from off to on with the LED, or would you perhaps want to switch that around? That works too. So we have a lot more control when we're programming with text, but don't worry about that if you don't get that. But the other thing we can actually do with this map function isn't necessarily just directly controlling the LED. We could actually convert sensor readings into something a bit more meaningful. Now, I mentioned the temperature sensor already, and that gives us, if we find out what the sensor reading values are, it gives us numbers between 20 and 358. But what does that mean? Well, actually, the temperature sensor in Tinkercad measures or would simulate a temperature sensor that measures temperatures in degrees Celsius from a range of -40 degrees Celsius all the way up to 125 degrees Celsius. Now, obviously, those numbers make a bit more sense. We can associate -40, that's really, really cold. 125, whoo, you're boiling water up at that point. But 20 and 358 doesn't necessarily make so much sense if we want to understand what the temperature sensor is telling us. So what we can do is we can use the map. We can take this input range from 20 to 358 and map it onto the actual temperature range that the sensor is able to measure. And that will then give us the actual temperature in degrees centigrade that the sensor is reading, which we can then use to make a lot more sensible decisions about what to do. Like if it's below 0, I'm turning the heating on very, very high. But if it's 125, then I probably want to turn a fan on instead, for example. So there we go. We've learnt lots of different tools already in terms of how to write programs using text instead of blocks. A lot of it is revisiting what we've done previously with the blocks and expanding on that slightly with the added flexibility that the text-based programming gives us. And we need to make sure we're using and remembering all of those tools because we want to use them all the time. For example, it might well be that we have a program that we want to be able to read from a sensor, and that will involve defining variables to record the pin for that sensor, setting the mode for that sensor, creating a variable to store the input from that sensor, and then having some condition, some if statement to be able to decide what to do based on the reading from that sensor. And any of those stages might involve calling functions, and those functions could be functions that are provided by the Arduino language, or they could be functions that we've written ourselves. So when we're programming, we use all of these tools at the same time. So it's really important to try and keep those in your memory whenever you're going to write a program, because they're all really useful tools. And think about when you might be able to use them when faced with the different exercises. And as the added extension for this week, we've introduced the map function more formally for text-based programming to allow us to convert between different ranges of values. As part of the exercises for this week, we're going to actually give you a new circuit rather than continuing on with the robot, so you can practice all of these different tools and making use of that map function to convert between different ranges. But don't worry, we will be going back to the robot, and as part of the challenge day, we'll of course use the robot as well. So thank you very much.